for us today is to extract policy points that then can be integrated in the policy proposals that are going to be submitted to the G20 and the different governments by the month of July. I don't know if Debashish or Dr. Vishwanathan, you would like to add any points in regarding the context?
Dorian, I think we have the 4 thematics, and on that we are trying to integrate policy. Especially we are looking at grassroots points coming from grassroots CSOs, which can be forwarded as relevant, important, and innovative additions to the process of policy making. And because the subject that we have itself is so related to grassroots, food systems, agriculture, and all, so I'm really expecting something that, you know, my professor Vishwanathan is also here, and we had a great course on agriculture with him. So we're really trying to look at value addition to the repository we have there. Sir, maybe you want to add something?
Yes, yes. Are you able to hear me?
Sure, sir.
Now, I would like to mention some of the questions before we begin. So maybe once we start, I'll raise those questions, which probably we can try to address. Of course, maybe they are already addressed in the speech, or we can also take some of them for discussion.
Maybe, sir, if there is some 1 or 2 points, just we have 2 more minutes to go before we start.
Yeah, basically, we would like to have some discussion happening on the challenges basically facing global food security, which are also hampering the ecosystem services provided by the natural resources. Basically, the compromise, the trade-off happening in the process of food production. Then also look at some of the traditional food production systems, whether we can think of some of the remedies coming from them. Then the other question is how far the companies, the CSOs, basically, they can make a big change in the whole process of achieving food security in the emerging context of climate change. And finally, also, we have several options like moving towards conservation agriculture or organic agriculture. Are they the real kind of solutions that we can offer? So these are some of the pointers probably we can highlight the discussion. Maybe in the discussion part, if we can highlight some of them, if the talk is not addressing them. And again, given the interest of Professor Krima, and actually she has also had worked on GMOs, so that part also we can actually touch upon whether GMOs, genetically modified organisms, can also provide problems, to the challenging problem of food security.
Thank you. Thank you, sir. Let's welcome Dr. Gangadharan also. He is with us. And good evening, sir.
Good evening.
You're welcome to the discussion, sir. We are on time. And Professor Vishwanath, if you are fine, should I start?
Yes, yeah, we can. Thank you.
Thank you, everybody. I welcome everyone over here, and I request our distinguished guests that we can switch on the cameras and be present. In a few seconds, I think we are good to start now. Om Amriteshwariya Namaha. My humble salutations and pranams to our C20 Chair Amma, Our Holiness Mata Amritanandamayi Devi, and my wholehearted greetings and a warm welcome to all the distinguished personalities present here. On behalf of the C20 India Working Group, that is Sustainable and Resilient Communities, Climate, Environment, and Net Zero Targets, I, Debashish Brahma, welcome you all to the C20 webinar today on reshaping agriculture and food systems to face climate and biodiversity crisis. Indeed, such an impactful topic. This working group, the Sustainable and Resilient Communities, is one of the 14 working groups under the C20 India 2023, which you might be aware, and it's also focusing on the thematic areas of climate resilience and social justice, environmental sustainability, net zero emission targets, and compassion-driven approaches to sustainable and resilient community. Just in case to set the context for the talks, adding to Professor Vishwanathan, the working group is coordinated by Dr. Manisha Sudhir, India coordinator from Amrita Vishwavidyapeetham, Professor Vinod Menon, who's the international coordinator. Professor Vinod is the regional director of Asia at TIMS Oslo and Brussels. Hopefully he'll be joining us shortly. And Dr. Atish Shivan is our international coordinator. He's the chairman of Amriteshwari Foundation from Malaysia. So we kind of have a very enlightened team spearheading the movement, and through knowledge sharing, multilateral and international engagements, and by raising awareness amongst the CSOs, policy influencers, academicians, public policymakers, the youth, we look forward to achieving the C20 India 2023 vision. You are the light. So just in case you're wondering who's the audience, we kind of have covered it all. As a part of the working group, we are here to explore pathways to build resilience in a changing climate. Building climate resilience involves a range of strategies, collaborations, and even land use planning, diversifying livelihood, social safety nets, strengthening ecosystems, and also promoting adaptive governance. That is where our policy making and suggestions are of primary importance, which is also the main motive of these webinars. For policy recommendations to the C20, these actions can also help reduce vulnerability and enhance the adaptive capacity, while also providing co-benefits such as improved food security, health, and biodiversity conservation. I'm sure you'd be equally delighted to join this series of discussions that has been panned and planned for the coming few months over this period of 6 to 8 months. But for today, let us invite our distinguished guests present over here, Dr. Ermias Cabral, Associate Dean of Global Engagement, Director, World Food Center at UC Davis. Welcome, sir. Dr. Angelica Hilbeck, Senior Scientist and Lecturer, Institute for Integrative Biology, ETS Zurich. Welcome, ma'am. Dr. Claire Kremen, Professor and President, Excellence Chair in Biodiversity, University of British Columbia. Welcome, ma'am. Dr. Baiju Gangadharan, sir, who's the Director of Central Tuber Crops Research Institute from our own India. So in all, we have a wonderful team here. And before I invite Dorian and Professor Vishwanathan to take over the session, let us have a moment of auspiciousness with a prayer. I request Vishak to please play the prayer for us. And please join me.
ध्यायामो धवलावगुण्डनवती तेजोमयीं नैष्टिकीं स्निग्धापाङ्गविलोकिनीं भगवतीं मन्दस्मितश्रीमुखीं वात्सल्यामृतवर्षिणीं सुमधुरं सङ्गीर्तनालापिनीं श्यामाङ्कीं मधुसिक्तसूक्तिम् अमृतानन्दात्मिकाम् ईश्वरी.
And on that note, though it's not a strict protocol, we are all aware, but let us hear a few words about Dorian Spack. Dorian Spack has his higher studies in the University of Technology of Compania, Urban Studies, Sustainable Development, European Affairs at EPFL, and then in the study in the Paris region on peri-urban agriculture. He's also the coordinator of Terracite since the last 10 years, and a wonderful human being and a very enlightened person on the subject that we have. Professor Vishwanathan is also with us. He serves as a principal at the School of Business, Amrita Puri, with special interests in economics of natural resource management and sustainability. He has a PhD in economics from the Institute of Social and Economic Change, which is in Bangalore in India. His research and teaching interests relate to economics, natural resource management, agrarian transformations, and rural livelihood aspects of technology, institutions, policies, governance, climate change aspects, and natural resources. Also environment and agriculture. Also conservation of biodiversity and ecosystems, and globalization and impact on agriculture and trade. So I welcome Dorian, and I welcome Professor Vishwanathan. I request Dorian to take over the charge of moderating the sessions as we move further. Please set the agenda, and so that the participants are also aware on how they can contribute to chat and Q&As. And I request Professor Vishwanathan to also jump in for introductions of the guests as and where he finds relevant. So I'll join the participants in hearing very meticulously on the proceedings further. Welcome everybody once again. Thank you.
Thank you so much, Debashish. Dr. Vishwanathan, I don't know if you want to have a word, or shall I proceed? Okay. So we're really happy having you here. Obviously, there's a lot at stake in agricultural and food systems. We have a lot of challenges coming ahead, especially with the climate crisis, the biodiversity crisis we're facing now today. And everybody is aware of the importance that agricultural systems have, both in terms of the share of greenhouse gases emissions they have, but also for the simple fact that all human beings need food to live, and food is the primary needs for all of human beings to be able to live on this planet. So I'm really grateful and happy we have such a wide panel today. We're going to be addressing 4 different topics, 4 different angles of the subjects today, with the specialties of the experts that we have gathered today. And we'll try to deepen a little bit these topics as they are addressed one by one, and then have a more transversal view and transversal outlook as of some of the policy recommendations we can bring forward to the G20 later on to try to improve public policy worldwide and address better the topic. I don't want to be too long in the introductions, so maybe I can introduce the first speaker we have today. So Dr. Ermias Kebrahab, who's the Associate Dean for Global Engagement in the College of Agricultural and Environmental Sciences of University of California, Davis, and also Director of the World Food Center. Doctor, it's an immense pleasure and great luck, and we're really grateful for the effort of waking up so early in California today and being with us with a very tight schedule. So thank you so much for joining us. Well, in the addition to all the positions I mentioned, you've also been a key contributor to FAO reports. You're actually the chair of United Nations FAO Technical Working Group on Feed Additives. You've also made important and great contributions to the IPCC reports, and especially the chapter 4 related to emissions from livestock and manure management. And I think with your life experience also, you have a very broad perspective on the world challenges. So we're really excited to hearing from you on what you see as your key policy recommendations to improve our management of the biodiversity and climate crisis in relationship to the food and agricultural systems.
Thank you very much, Dorian. Thank you for the introduction and for the invitation to come here this morning or evening in some parts of the world to talk about the challenges that's facing us. So I'm going to be focusing on the livestock. Let me just share my screen. Okay, so I hope everybody can see this. Right. So when we talk about sustainability and how we'll be moving forward, we hope that, or we're trying to work towards an agriculture where we have net zero emissions. Whether we will be able to achieve it or not it's a different matter, but at least each industry within agriculture needs to do something to work towards this net zero goal. And why livestock, or why are we focusing on this? Why in agriculture? Well, although about 3/4 of emissions are coming from the energy sector and transportation sectors, agriculture also contributes to greenhouse gas emissions. And if you break it down, we'll see that about livestock and manure, close to 6%, and we have agricultural soils. That's also emissions to provide feed for animals, rice cultivation, and so on and so forth. So there is a considerable contribution of the agricultural system to greenhouse gas emissions, and we're trying to reduce that as much as possible. If we look at what are the solutions available to us to try to get to net zero, quite a lot of it is to do with the production of animal protein, or in general, the livestock industry. All the sort of the light blue ones you can see here are to do with livestock. For example, looking into genetic selection and breeding, optimizing the animal feed mix, looking at improving digestibility, particularly in low and middle income countries, looking into increasing livestock production efficiency, looking into animal feed additives. So a number of those things are really related to livestock, and we do have a lot of potential to reduce those emissions from the sector. And one thing that gives us a little bit more hope is that a lot of the industry have made commitments. For example, in the US, the beef industry has made a commitment to achieve climate neutrality by 2040, and the dairy industry has commitments to achieve a similar greenhouse gas neutrality by 2050. And a lot of the industry around livestock also have commitments that have publicly expressed. And so why are we focusing on methane? Well, if we look at the contributions for emissions over 100 years, the pre-industrial revolution and now, most of it is through CO2, but 0.8 degrees centigrade, but methane is 0.5 degrees centigrade. So although 80% of the emissions is through CO2, but the impact on the environment, particularly on the temperature and the warming of the planet, methane has an oversized kind of contribution. So there's been a lot of focus into it. And there has been some policy targets to try to curb methane emissions. At COP26, for example, there was a lot of effort, and the US and the European Union suggested the creation of this global methane hub and having a global methane pledge to reduce emissions by 30% from 2020 levels by 2030. And last year, in COP27, the number of countries grew to 150. So now we have 150 countries that are committed to this. And if they meet the targets, that means that we will save about 0.2 degrees centigrade warming by 2050. So it's quite a significant amount of reduction that we would expect through this initiative. And we have other policies, local policies. For example, in California, we have a mandate to reduce methane emissions by 40% below the 2013 levels by 2030. And then kind of a midway assessment that we've done recently shows that we are about 20%. So we'll meet half of what we wanted to do by 2030, the way that we're going right now. So we need to change a little bit, and we do have some new tools that we can employ to help us to get into that situation. So what do we need to do? What kind of actions need to happen in order to be able to come below the 1.5 that the Paris Agreement has stipulated? Well, the very recent IPCC report shows us that we need to start reducing right away. So there is really no time to waste. Even the limit warming to 2 degrees centigrade, there's not much time left to start reducing. So we need to start reducing, and we need to reducing very fast. So what would happen is this is a simulation that we've done to see where we need to be and what kind of reductions we need to conduct. The blue line here is methane, the orange is nitrous oxide, and the black is the combination of methane and nitrous oxide. And we are looking at, on one side, the cumulative emissions, and on the other side, looking at the estimated warming that would happen compared to 1990. And what it shows us is that if we're able to reduce emissions from cattle by 50% by 2030, and then continue to reduce by 1% per year, then it will take us into a negative in terms of warming, a negative warming by 2050, and kind of net zero by 2040. But then the nitrous oxide situation is still quite important, and we need to focus not just on methane, but on nitrous oxide situations as well. So what kind of things can we do to help us get there? So we looked into this, and we published this last year, several different ways of effective strategies to try to reduce methane emissions from ruminants, and to try to help us stay below the 1.5 degree centigrade target. So one of the things, this was not in that paper, but this is becoming more and more important, is try to limit the consumption. There is quite a big disparity in terms of how much animal products, particularly meat, is being consumed. And globally, we are consuming 90% more than we actually need, and so that needs to go down. In Europe and North America, so the average is about 70 kilograms of meat per capita, while in Sub-Saharan Africa it's about 10. So a lot of places will need to come down, and some places, like in Sub-Saharan Africa, needs to increase the consumption as well. So it's not overall reducing the consumption everywhere, but there are communities that actually need to increase because of lack of micronutrients and all that. But a lot of communities need to reduce their consumption. From the work that we've done, we kind of identified three strategies that are product-based reductions. So things like increasing the feeding level that is relevant for house animals as well as grazing animals, improving digestibility if it is in grazing animals, looking into grass maturity, and also changing the forage to concentrate ratio would also help us reduce emissions. In terms of absolute reductions, we have a number of things that we are that we have available for us now. Things like methane inhibitors, tannins, and electron sinks, and then lipids in different formats of lipids will also help us in reducing the methane emissions. One thing we have done is to try to compare what has happened over the last 50 years in dairy in California. Here you see that in the red is in the 1960s, and then the blue is in 2014. And you see that there's quite a substantial reduction happening, and that is mainly related to the genetics. We have animals that are much more productive now, and we have also crop genetics that are yielding a lot more now for similar inputs over the last 50 years. So about 45% reduction has happened, and we continue to do this as well. This graph shows really nicely, well, as you improve productivity, both in milk yield and in animal gain or meat production, you can see that the more production there is, the lower the methane intensity. So per kilogram of milk or per kilogram of beef that you're producing, the more productive you are, the much less reductions in methane intensity. So in some cases, 5 to 10 times lower methane intensity as you improve productivity. So one of the things that we are working on is to put together a ration formulation tool for countries that are interested in improving productivity. So far, we've done the countries that you see here in the languages that they speak. So, for example, in Laos, it's in Lao language, and then you can select the type of animals you want to do that. And we're going to expand this. We are working with Global Methane Hub at the moment to try to expand it to India, to Indonesia, Thailand, Vietnam, and the Philippines, and also a number of countries in Sub-Saharan Africa as well. In terms of absolute reductions, we have a number of feed additives that are shown impacts or reduction impacts. One of them would be seaweed, quite a big impact there in terms of efficacy. This doesn't say anything about the ease on which you can include it into different production systems, but the efficacy, we can see that a number of feed additives are quite efficacious and we can include them. In terms of what happens if we're able to include them, this is a paper that came out just a couple of days ago, where it shows that by 2030, if we use supplements to reduce emissions, then we can actually go into a negative CO2 warming equivalence. So this is one way of looking at it, but in general, there will be quite a substantial reduction by using those kind of technologies now. As Dorian mentioned, we have put together a very detailed document on methane. This will be launched on September 13 in Rome. So after that period, it will be available to everybody. It will be freely downloadable, and then you can learn more about methane emissions as well. I just want to mention a couple of things that we are doing now. We just received a substantial funding to work on CRISPR, using CRISPR to cut methane emissions from cow guts. This is a collaboration between UC Davis, UC Berkeley, and UC San Francisco to try to come up with a completely different way of looking at these things. And we may have 20–30% chance of being successful, but if we are successful, it means that almost complete elimination of methane from cattle and improvement in productivity. And finally, just to conclude, we will see an improvement in feed efficiency to continue. We will also use feed additives soon once they start to be approved, particularly in US and Canada. And we're working on genetic selection that will give us reductions by about 10 to 25%. And also working in manure management. And for example, in California, we put in 118 anaerobic digesters in the last few years. That has helped reduce emissions from dairy operations. So I think there's a lot of policy that has pushed a reduction in emissions. So we can learn a lot from the policies that happen in California, where there is a cap and trade system, and that kind of pushed the emissions reduction. Over the last few years, California has made about $20 billion in this cap and trade system, and a lot of that money has been spent on trying to research on reduction of emissions from different sectors of the economy. So I think there's a lot of policy decisions that we can learn can be implemented worldwide. So thank you.
Thank you so much, Dr. Kebrahad. That was really interesting indeed. A few points maybe on the fact of the first point that you mentioned to improve is to eat less meat. And I think that's really interesting in the setting we're in today, because India, for instance, has a culture of a very large portion of the population being vegetarian, whereas in the West, we've been raised and born and fed with the idea that meat was a really essential item of our daily consumption, and that was actually an indicator of well-being and wealth and everything. And I think the cultural dimension of changing diets is a really interesting parameter to study, and also something really important to take into account in terms of policy making. Maybe a small word of you on that sense, like how do you think there's a chance in the West, like in Europe, in the US, we can actually trigger the cultural leverage to actually help people change their behavior on that point?
Oh yeah, so I think cultural shift and changing the behavior of people is very, very difficult thing to do. So I don't know if we are able to do it through legislation. I think that there has been a lot of education that's happening. I think it's not just for the environment, but also for health reasons as well. The reduction in some areas. I mean, as I said, there is a disparity. So, like you said, in Western communities in Europe and US and North America in general, yeah, we've been trained. Consumption of animal food products is one of the important things, but I think we're learning more and more now that we need to, particularly the ultra processed foods. I think there needs to be a limit as we see things like obesity and all that really exploding, not just in North America, but even in low and middle income countries as well. A lot of it's to do because of the overconsumption of ultra processed food, whether it is plant-based or animal-based. I think there needs to be some way of trying to curb that, and I'm not sure how exactly that's going to happen, but yeah, we need to significantly reduce ultra processed foods in general.
And that's very interesting, because actually the main conclave of our working group was happening in Sikkim in India. And I think all of you know that Sikkim is the first Indian state to have gone completely organic. They grow only organic food since a number of years now. And some representatives of states were then mentioning that they have made all the efforts internally, but they're exposed to the very same problem that the population still craves for ultra processed foods. And so they still import a lot of ultra processed food, whereas internally to the state, they only grow organic now. And so there's a big culture shift there that needs to be addressed at the global level. And so thank you so much for the contribution. And then I noted the role of research, science and innovation, that actually science and innovation can help us really improve the balance of the global methane production. And the figures you mentioned, I think, were really, really interesting in that sense. And thank you so much. I know you've been really involved in the work around seaweeds, especially. So thank you so much for that contribution. We saw the effect it has. And then obviously genetic selection and the manure management. So all policies going in that sense would be helpful, and we'll put that forward in the proposal. Thank you so much, Dr. Kebrahab. Maybe Dr. Vishwanath, I don't know if you have a word to say.
Yeah, am I audible? No, I just wanted to say thank Dr. Kebrahab for his excellent speech. Let us move on for paucity of time. Let us go to the next speaker. I would like to invite Dr. Angelica Hilbeck for a talk. Just wanted to introduce her briefly. Dr. Angelica Hilbeck is a senior scientist and lecturer at the Institute for Integrative Biology and the Department of Environmental System Science at ETH Zurich. She's a well-known German-Swiss agroecologist. Her work focuses on the environmental biosafety of genetically modified plants in ecosystem. Her teaching and research is concerned with environmental risk assessment, ecological biosafety of genetically modified plants, and farmer participatory agroecology research in Eastern and Southern Africa. Through her international work with the UN, governmental and other non-governmental organizations, she became increasingly involved in broader issues of technology development, particularly genetic engineering and digitalization, towards a democratically legitimated, sustainable global future, and actively also contributes to the debate on biosafety, international agriculture, hunger, and poverty alleviation. Dr. Hilbeck has also been involved in the negotiations around the implementation of the UN Cartagena Protocol on Biosafety. She was also an appointed lead author to the International Assessment of Agriculture Knowledge, Science and Technology for Development, and also served on various boards of civil society and scientist organizations, particularly European Network of Scientists for Social and Environmental Responsibility, then Critical Scientists with Switzerland, and then Federation of German Scientists and the Swiss Development Organization Board, etc. So let me invite again Dr. Angelica for her wonderful speech. Thank you so much.
Thank you so much for the extensive introduction. I'm trying to share my screen and hope it'll work out. Can somebody give me a nod if you see
it works perfectly.
Okay, very good. So without much further ado, let me dive into the issue. I'm not going to speak about biosafety issues today, but rather about what I've been doing a lot in recent years, and almost a decade now already, is how we can transform the agro-food system locally and globally, because through my work on biosafety and environmental issues, I did realize that this is far too short thinking. We need to think more deeply and more long-term and more systemically how to change our agro-food systems. We know today, and I don't think I need to explain it to this audience, that our Earth ecosystem is responding to the totality of all interventions we have made. We are looking now at the land uses and the land issues, but there is other issues that are converging as well on our self-supply and our sustainability of human populations on this globe. We must keep that in mind when we break it down to what we can do locally, that we don't lose sight of the larger picture that we're in. And I'm personally became a total fan of going after the root causes of why is it that we are facing these converging crises right now. And much of it has to do with the fact that we were implementing and applying a mindset to treating our planet and the systems of our planet that in all walks of life. And it's this industrialized concept that we have been applying everywhere. We not only have been applying it in mechanical engineering and producing goods, but also in how we treat the environment. So when we speak about the contribution that agriculture does to all of these issues, climate change, etc., we must keep in mind that this is not all agriculture. It is one form of agriculture that does that. I find this very important also when we want to build counter proposals or proposals and give us hope that we can change the path of humanity on this planet. So it's the industrial forms of land use that we've applied not only to agriculture, to forestry as well, plantation farming, etc., which was modeled basically after the mindset of mining. You know, whether you mine now ore from underneath the soil, minerals, etc., you were mining nutrients and mining commodities, raw materials for industrial processes from just the humus part of the soil. And that needs to change, because these types of how we dealt with our ecosystems have led to massive problems, not only climate change, which is, you know, a big concern today because that's what you hear in the media. Second, biodiversity is in a much more dire situation here, but also all kinds of other resources and planetary operation systems that we need to sustain humanity on this planet has come under severe stress and threat, be this fresh water or biogeochemical cycling and flows. Novel entities means largely chemical pollutions of all sorts and fashion, land use system in general, etc. And in all of these, the interesting part is all of these, the way we were producing food, our agro-food systems have had and continue to have a decisive input. So it's not only the methane emission or CO2 emission, it's chemical pollution, it's a lot of more things, oil consumption, etc., resource consumption that is contributing to that is all can be allocated to the agro-food system in the wider sense, not just what we're producing in a field, but also the processes all the inputs that go in there, all the energy that need you for the inputs that go in there, all the post-harvest processes, the transport processing, the distribution, etc. They all go into that chunk of what contributes to the problems. So we do need holistic solutions to this problem, but how we can do this is the key question. I think also what concerns you at the C20, informing the G20 on what they better should doing if we want to sustain human populations in peace on this planet. So I personally believe that we need to build bridges. We need to combine and have transdisciplinary efforts, including all walks of life, between academic disciplines, arts, technologies, science, etc. But we also need bridges between academia and farmers. And I mean, not necessarily the industrial farmers, because those are the farming systems we need to change. We need to work with those farmers who carry some of the knowledge and carry the understanding how we can make use of what they know, their knowledge to the systems in order to convert and build up and scale up the healthy forms of producing food. So we need transsexuality as well in this, and that is very tricky because we've all been siloed in our disciplines. How we can do this is a key question. So for me, there is a dual approach that is necessary for transforming our agro food systems. We need to learn and upscale and understand some of those lower efficiency systems that still exist out there. In fact, they're feeding most of the peoples in Asia and in Africa, for example. However, they need to be upscaled and maybe intensified to a certain degree with an economic framework that rewards and enforces those systems and contributes to establishing short value chains, local and regional markets, etc. And in duality to this, in parallel, we need to transform those destructive, environmentally destructive industrial forms of agriculture. That is not possible also without co-transforming the economic paradigm that rewards these kinds of systems right now. So we need to start shifting those away and redesigning them from the bottom up, otherwise it won't work. So for me, these are kind of the two contrary ag food system models that we need to understand how they function and where we need to get. Where do we need to go away from and where do we need to end up? So industrial productivity narrative and systems are usually single functional. They're focused on yield, single monocrops and profits out of that. They're producing raw materials that form the basis of a long value chain along which you recoup the profits. It's an open linear extractive system. It's with high external input reliant, and it totally externalizes all the harm, whether this be environmental harm or social harm. Now, agroecological systems are usually multifunctional. They feed local populations and they have multiple purposes for feed, medicine, energy, building material, clothing material, etc. They're usually short value chains, local supply, could be in grid structures. They're closed recyclical system. I think that is an absolute key. And it's little to ideally no externalization and external inputs, nor externalization of the harm. It internalizes by default those harms into it. So we need to get away from this. And we need to move to agroecological systems. And that is, in fact, what I'm seeing now over the last 10, 15 years. There is a lot of momentum gained in the agroecology field. As it has been understood that we need to transform our systems, we started to understand that we have something to build on. We don't have to start from scratch again. We have a concept and conceptual understanding of how to transform our systems towards more what used to be an agriculture. There's a term culture in agriculture, and including the ecology. So it's in principle the application of ecological principles, so the rules of law of this planet, including into the way we do business as well, how we trade, which means it's not a prescriptive system like the industrial model was. It has to be locally configured according to what the environment allows locally you can do. It's a scientific discipline, an agricultural practice, and a social movement. That's by and large usually how it is defined. However, I add usually a fourth dimension to it, and I call it the art. Because it's an artistic understanding, almost an intuitive understanding you also need to understand what's possible in a particular situation, in the context that you operate in, be the social and environmental context. Now, we don't, as I indicated, we don't have to start from scratch. We have test systems available. For example, the ancient millpot traditional farming system, which is a brilliant system between maize, beans, and squash. I'm not saying that we have to do as it was, but these are bases we can start from. We have a system that's called a system of rice intensification that was developed more recently, also in conjunction with smallholder farmers, traditional farmers, and a person of faith, a man of a church in Madagascar in the 80s. We have systems that have been developed with farmers and scientists in East Africa, the push and pull system that combines a lot of different uses that you have for food, but also feed, and for biocontrol of pests and diseases there. And we have made our own little contribution in how to devise and to develop a technology tool for farmers to exchange their knowledge and their understanding in agroecology, which we worked with in East Africa for 10 years. Meanwhile, now this is a much Saudi platform we call, where farmers can use handheld mobile phones, an application we have co-developed together with them. So they were the ones who said what they need. They were the ones who said how this should be configured. And we had programmers who then put this into work for the farmers. I think I'm out of time, probably pretty much. So I will skip the next slides largely, other than just explaining to you briefly that we used a methodology like the rich pictures methodology that farmers understood, and we built that there are methods that you can build on with local communities to even develop high-end applications and ICT tools. So it's possible, but you do need very different attitudes, and you do need you need to develop the language that you can communicate with communities across sectors and across disciplines. And I think I leave it here at this. If anybody wants to know a little more about this, we've published all of this, and maybe in the discussion we can go into this as well. Thank you very much.
Thank you so much, Dr. Hellbeck. And maybe as a small wrap-up points for this, I would say that you started with this whole idea that the industrialized mindsets is the cause for many of the difficulties we're facing today. And yes, you highlighted that it's basically one, we should never forget that it's one form of agriculture, and actually the vast majority of farmers, especially in what we still call developing countries, but maybe that's not completely right, are actually small-scale farmers. I think India's case is particularly striking, where 50%, more than 50% of India's population is consisting of small-scale farmers, and more than 85% of farms in India are less than 2 hectares. So definitely out of the systems you were mentioning. That's not the case in the United States, in Europe, in France, where I'm speaking from. And so that's maybe one question for you. I think that's really interesting to know how you see in our countries where large-scale farming has become the main driving force. How do you see we cannot do this transition without the large-scale farmers? So you spoke on how you can discuss and support the small-scale farmers, but how do you see the transition from the large-scale farmers that are there, and what is the role of policy in that regard in helping them change their practice?
Right. Well, we see a little bit the EU is kind of starting to move towards that. So, but I think there's still way too much top down. So it's met with resistance now. So they've given policies like cut pesticides by 50% by 2030. I think my previous speaker was mentioning emission reduction by so much, and then it just is kind of, put from top down. Now you go and figure out how to do this on your own. So I think we need to have a combination of research efforts that are going towards this goal, but we need to take the farmers along with us. Also the industrial farmers along with that, very much so, because they feel right now very much alienated in some of the regions and feel like they're being called now on to be, at fault and be the ones who did all of this. That's not true either. They were coerced in some instances into these forms of production, or they would go bankrupt. So we need to change economic systems, the reward system. That's very important for us, and we need to do it together with them and a collective research effort. There's not so much different in how to do this between developing and developed countries. It's a community effort. Regardless who you are working with, you need to bring them all together. Don't do it top down, then it will be met with resistance.
I think there's a lot of passion here, and I think
yes.
it comes also a lot to what you were mentioning about culture and maybe a vision where we all collectively go together. So I'll keep that for the last round, because I think that's one of the binding things that will gather us in the end. And maybe Dr. Vishwanathan, if you ready to proceed.
I just wanted to share a concern here, because the place I'm talking here from Kerala, which actually, which is a state in India, one of the states, southernmost states in India, where we have gone in more towards industrial agriculture, rubber plantations, monoculture rubber plantations assume almost 26 to 27% of the state's land use. So, which is a very interesting point that you have raised, how we actually move away from this industrial agriculture towards the agroecological approach. It's quite interesting to talk about it. Maybe we can have more questions at the end. So let me now introduce Dr. Claire Kreman. She's a professor and a President's Excellence Chair in Biodiversity at the University of British Columbia, where she leads the interdisciplinary biodiversity solutions collaboratory and teaches on social ecological systems and biodiversity conservation. Her research focuses on how to improve the connectivity and sustainability of farming landscapes through agriculture diversification. Previously, as a professor at the University of California, Berkeley, she co-founded the Center for Diversified Farming Systems and Berkeley Food Institute. Her experience includes working for the Wildlife Conservation Society and the Cerces Society to establish protected areas and document biodiversity patterns in Madagascar. She has named a MacArthur Fellow in 2007 and Volvo Environment Prize laureate in 2020 for her work on biodiversity in agriculture. She's also a chief editor of Frontiers in Sustainable Food Systems. I'm very happy to say that I'm also one of the review editors to this journal. Thank you so much. So now I invite Claire for her excellent deliberations. Thank you.
Thank you so much for that introduction and for having me join this important panel. And I hope you can see my slides okay. So my talk follows very well after Angelica's talk. And of course, we have only one planet. The pressures on that planet, as she has, as both the prior speakers have already described, are so enormous. Agriculture to produce the food, fiber, and biofuel that we need it contributes so much to these enormous environmental pressures. And it's a very multifaceted problem. Of course, the greenhouse gas emissions, a contribution to climate change, but the way that, agriculture is using so much of the land on the planet, so much of the water, contributing so much to tropical deforestation and to pollution. And so at the same time, it's not actually producing the food that we need for healthy diets. And this industrial form of agriculture is not climate resilient either. So we just have to change agriculture. I think there's just little doubt. It cannot just be about production. It cannot just be about making enough food, enough crops, enough livestock, enough forest products, but it has to be multifunctional. When we think about, every single field that we have out there, we really need to think about that multifunctionality everywhere, that we're producing not only the food production, but also taking care of the soils, making healthy soils, ensuring that that water is stored in those soils, that we have the quality, freshwater quality, that we're not polluting the water, that we're also taking care of the important biodiversity that contributes to agriculture, the pest control organisms, the birds, the insects that control crop pests, the pollinators that we need for producing a lot of these crops. We have to take care of this fundamental environment within the farm and around the farm in order for it to be regenerative. And that's a key component of the agroecological perspective that we just heard about. So, and it's not that we don't know what to do. I think that we do already know what to do. And this is really where I want to focus my talk, and showing you some of the science that we've synthesized that strongly shows how, through rediversifying, getting away from that monoculture, rediversifying agricultural landscapes, using key agroecological practices and doing this across scales, that we can create a regenerative and multifunctional agriculture that is also productive. And so here's a whole array of different kinds of practices. We call these agroecological practices. We call them diversification practices. And they make key contributions to these key elements on the farm that farmers need. And sorry, I'm having a little bit of trouble with my, there we go. So this is just a pictorial representation, but there's a lot of data behind this as to why these different single techniques often have multiple positive benefits on these various factors that farmers need to manage in their fields. And we've synthesized this information through a technique called meta-analysis, which brings together many, many different studies into a single study to look what's the overall trend. And so this is the evidence base supporting the regenerative nature of these diversification practices. The way to read these graphs is that if you see that the mean here is well to the side of 0, that means that the diversified practice compared to the simplified practice has a positive effect, as long as these confidence intervals around it are also on this side of the graph, away from this dotted line indicating 0. So you can see here that for many of different environmental performance factors, we have positive effects of all the diversification practices, many diversification practices I showed you a list of previously, on these various environmental performance indicators, whether it's biodiversity, pollination services, pest control services, nutrient cycling, water regulation, soil fertility, and carbon sequestration. And then when we look at crop yield, we see that it's a neutral effect. So it's about 50-50, about half of the studies are showing actually positive effects on yield, and the other half may be showing that there's some reduction of yield. Another study confirms these positive environmental performance of diversification. This study focused on a smaller set of diversification practices, but it also had a larger amount of data. And so again, we see many positive effects on the environmental performance side. The study also found that there were positive effects on yield as well. And here you want to focus in on just this darker line here and the little circle, which is the mean and the confidence interval. And you can see that up here too. So here, finding yield benefits, we also have various scientists have looked at diversification effects on the profit side of things. And there's many fewer studies here, but the overall effect is positive and significant for diversification of practices on profitability. However, when you look at different kinds of production practices, you see that there's quite a lot of variation. So some practices might be less profitable, whereas other practices are strongly profitable. However, overall, with this positive and significant effect, it dispels the myth that only monoculture can be profitable. It also suggests that incentives are going to often be needed to encourage use in some cases where profitability is not yet achieved. And this can be this can be also due to the policy environment that isn't actually favorable, isn't providing an enabling framework for these practices. And then another important aspect with this particular study was looking at for a subset of these studies that had labor costs included, that the labor costs often do increase, which is a concern, but because the gross income was also increasing, net income remained equivalent. So I want to give you briefly 2 examples of diversification. I want to talk about how this can be applied to these industrial monocultures that we've been talking about, but also how these can be applied to smallholder systems. And I'm just going to give these 2 examples as an illustration. So this first one is diversifying some of the most intensive monoculture systems in the United States, the corn-soy system, which is a very makes up a very large portion of farming in the Midwest of the country, and is also responsible due to an enormous amount of pollutants, nutrient pollution that is responsible then for creating this large dead zone in the Gulf of Mexico. And just recently, the USDA, the United States Department of Agriculture's research service, has invested in a 5-year research program looking at one technique, winter cropping. In other words, adding in a second crop, and in this case, using oil seeds before the main crop of soy to provide a continuous soil cover. And you can see some of the different plants that they've been using to do this. And they found, I'm just going to summarize a lot of research that they've done. They found a number of different benefits. Again, getting at that multifunctionality that I'd like to emphasize here, that it increased the total oil yield, it increased the land use efficiency, so it could produce more on a smaller land footprint. It reduced the nitrogen losses coming off of these fields by an astonishing 90%, and also reduced soil loss. It increased weed control and allowed the reduction of herbicide use. It improved water conservation and provided some drought resilience from this. And it increased floral resources for pollinators. So one single technique, just adding in and having continuous soil cover, all of these different benefits without reducing yields. My second example is integrating trees and shrubs as forage into pasture for farmers in Colombia. And here you can see that there's, with this typical farming system, which is just grass pasture, lots of negative environmental impacts, loss of soil fertility. You can see the erosion that's happening. Eventually the land becomes exhausted, and this leads farmers to leave their patch and conduct further deforestation. It's an inefficient production, which enhances the cycle of poverty. And there's a social vulnerability due to that, and also great risk to climate change as it's not a drought resilient system. So here it's a much more complex diversification practice, going from these monoculture grass pastures to integrating a variety of different kinds of plants, both trees and shrubs, into the pasture. Again, it creates multiple benefits. One very important one is it's a restoration technique. It restores these exhausted lands, and then farmers don't have to leave. They don't have to move on and continue deforestation. It also improves meat and dairy production per hectare by quite a large amount. It improves water storage into the soils and promotes drought resilience. It reduces fertilizer and pesticide use because of reduced input use and greater production. It also increases the profits on the field. And it reduces greenhouse gas emissions per ton of meat produced while providing habitat for biodiversity and carbon storage into the soil. So again, very, very multifunctional. So I wanted to emphasize these two different kinds of systems because we were talking before about industrial monoculture and industrial agriculture. Can anything be done? Yes, lots of things can be done. Lots of things need to be done to make those systems less polluting. Then on the contrasting side with smallholder agriculture, which is often inefficient and isn't providing the food that people need, again, a system of agroecological intensification can be used to make those systems much more productive while still maintaining their environmental benefits. But there are a lot of barriers to adoption. Because if there weren't these barriers to adoption, we would see these agroecological diversification practices being used so much more often. And one of the key ones is that there's upfront costs. Often it's difficult to make a transition into one of these more complex systems. There can also be initial yield losses while learning, or due to the need for recovery of the degraded system. So a silvopastoral system, for example, isn't going to be immediately productive. And because of that, there needs to be access to credit or incentive programs to allow farmers to take up these other kinds of systems. Another key factor is about land access and land tenure. When it's lacking, there's no incentive for doing these kind of longer term investments in sustainability practices. So this might require having land reform programs or land tenure programs. And a third factor is that these methods are knowledge intensive. That's both their beauty, but also the difficulty of making them, of getting them out to larger scale. And so this often requires some assistance to farmers. It could be that we need investment in applied research that's tailored to specific crops, livestock, and regions, such as what I showed you for the USDA. That was a 5-year research program targeted to a specific crop and farming system. But for agroecological research, it tends to be vastly underfunded compared to the similar equivalent in more industrial scale agriculture. We also need investment in extension programs and in farmer to farmer peer learning programs, which are some of the most effective. And then finally, it can also, another barrier can be the lack of access to appropriate equipment, seeds, breeds, rural infrastructure, and markets that may be lacking. And so there we need government assistance programs. And I'll stop there. Thank you very much.
Thank you so much, Dr. Kremen, for this very comprehensive outlook. So I think you started emphasizing that there is a whole range of practices that are already known that can help us in a big way getting the systems evolved now, and that the science has proven now that the myth that only monoculture can be profitable is a myth, and that there's other systems that can definitely bring financial returns, but also a number of other societal returns in terms of practices. That the solutions are known, and you gave the examples, the very concrete examples of the winter cropping and the hedges, the trees, the shrubs that could be included in raising animals. One of the things maybe regarding winter cropping, it's more a recent question, because I had this discussion with farmers trying to convince them to go for winter cropping, and then they were saying that they're a little hesitant because of climate change influencing the amount of rain that they may get, and that winter cropping may use some of the water resources from the soil to grow in the winter, and that the water resources then may be less available during the rest of the year. Do you know if there's some
yeah, in this particular example, they found the exact opposite, that it was actually helping to keep water in the soil. And they looked at that specifically. But I think that the broader point they bring up is that often there are concerns, farmers will have concerns about a technique that they're not familiar with, that they haven't used. And I don't want to minimize that the trade-offs do exist. There definitely are trade-offs. I also want to emphasize that while we know a lot broadly, the devil really is in the details. And to convince any specific farmer growing specific crops in a specific place, it really does take the kind of research that I just showed you. Both of those examples actually have tons of research behind them. And Angelica also showed the push-pull system in Africa, for example, the very, very research-driven development of those systems. Researchers working with farmers is absolutely the best way to go to find out what are the problems they're concerned about. Are they, with like this cropping system possibly stealing the water? And, essentially developing systems together that deal with each individual set of crops in a region. That's super important, and we just don't have enough of that. Yeah.
Thank you. I'll propose to keep that also for the last part, because I think the way we transition is really an important part of the final discussion. And maybe Dr. Vishwanathan, if you would like to introduce our last speaker today.
Yes. Yeah, thank you so much. Let me now introduce the last speaker of the day. We have Dr. Baiju Gangadharan. He's the director of the Central Tuber Crops Research Institute, which is located in Kerala. Dr. Gangadharan is a soil scientist specialized in site-specific nutrient management and abiotic stress in tuber crops. He developed a climate-resilient agriculture for tuber crops and validated 5 models for climate change modeling studies. He also completed 42 institute research projects and brought about huge funding in terms of external aided projects, etc. He also mentored several scholars, postdoctoral researchers, PhDs, master's students, MTech students, etc. Also acted as an external examiner for a large number of students, PhD as well as masters, for master studies in different universities, agricultural universities, especially the Wageningen University and Research. He also published quite extensively. He has more than 100 refereed public journal articles published in peer-reviewed journals. He has also been working in the Indian Council of Agriculture Research, CTCRI India, for the past 31 years, and also continuing as the director at the Central Tuber Crops Research Institute located in Trivandrum in Kerala. Thank you. Let me invite now Dr. Baiju Gangadharan for his speech. Thank you so much. So you may just minimize this and then you're visible.
Good evening, everyone. Just I'm trying. Actually, I lost my power, and just I'm trying to reconnect. So is my presentation visible?
Yeah, it's fine, sir.
Okay, thank you for the introduction. So in continuation of the lectures by very eminent panelists, I will be talking to you for a few minutes about another important sector in agriculture that has got a very important significance in the coming years of climate change. They are actually tuber crops. So my topic is on tuber crops for sustainable agri-food systems under changing climate. So we know that out of the 17 sustainable development goals that we are aiming to achieve by 2030, the second one is actually intended to end hunger, achieve food security, and improve nutrition and promote sustainable agriculture. So just if you see the definition of food security, during 2001, there is a slight modification in the improvement in the definition of the food security. That is when all people at all times have physical, social, and economic access to sufficient, safe, and nutritious food, which meets their dietary needs and food preferences for an active and healthy life. So that social aspect in food security has been introduced by the State of Food Security Insecurity Report during 2001 as an improvement of its definition of 1996. And this is a very important publication of the publication led by the Food and Agricultural Organization of the United FAO, we all know. And there are very certain stark realities which says that 670 million people will still be facing hunger in 2030. This is one of the latest reports of FAO, which says that 670 million people will still be facing hunger in 2030. And another very important point to be noted is 2.3 billion people in the world were moderately or severely food insecure during 2021. That is about 11.7% of the global population. And also in 2020, 22% of the children under 5 years of age were stunted, 6.7 were wasted, and 5.7 were overweight. So if you see the recent times, we can see some of the major 4 important drivers of recent food security trends are a number of conflicts. Then climate variability and extreme, we all know that is the most important issue that is facing the sustainability of food systems. Then economic slowdown after the COVID pandemic, and COVID-19 pandemic itself is these are the 4 important drivers that is actually very seriously affecting the food security globally. And in this context, a food system approach, as indicated by most of the earlier speakers, is very important to look into a food systems that are extensive networks made up of everything involved in not only production, but storing, packaging, processing, distribution, marketing, consumption, and disposal of food, including the social, political, economic, legal, and environmental systems. So in contrast to food systems, when we look into agri-food systems, that is actually, it encompasses the primary production of food, not only food, non-food agricultural products also, as well as in food storage, aggregation, post-harvest handling, transportation. So everything from farm to fork is taken into consideration locally when we develop agri-food systems, which has 3 important components: the primary production, then the distribution of food, linking production to consumption through food system chains, and household consumption. Now coming to how the climate change affects crop productivity, I will skip some of the slides because these are general information. We can classify the effect of climate change on crop productivity into group 4. There are influences on soil resources, then plant resources, mainly the diversity of plants, then its effect on yield as well as quality of the produce. Then it also affects field operations, many of the climate vagaries. And the indirect effects are weeds, infestation of weeds, insects, and diseases. Now coming to my topic of interest, that those are tropical tuber crops, are a group of about 10 to 15 crops, mostly grown in the tropics and subtropics, of which the important ones are: number 1 is cassava, and number 2 is sweet potato. Then comes yams, elephant foot yam, taro. These are the major important 5 tropical tuber crops that have got a very high significance in the future years in the time of climate vagaries. They are considered as future smart crops. The UN has declared this year as the International Year of Millets. Along with millets, tropical tuber crops, especially cassava, are also considered as climate resilient crops, and they have got a very important role to play in the future, especially in the agri-food systems and sustainable production intensifications. And if you see that these statistics show the importance of roots and tubers, which is about 63.53 million hectare of area is under roots and tubers, compared to wheat, rice, and maize, the other important staple foods. These roots and tubers have got a very important role to play. If you see the area as well as if you see the production also, the roots and tubers, the production is more than the production of wheat or the production of rice, the total production of root and tuber crops, which show its importance. Now coming to the most important, I will emphasize on this crop, especially cassava. It is a food of the poor people across the globe, in Latin America to sub-Saharan Africa to Southeast Asia. If you see most of the tropical belts, 80% of the cassava area and 64% of the cassava production globally is in African countries, followed by South America and some of the Southeast Asian countries. And this crop has got multifarious uses. It is actually a multi-purpose crop because it can be used as human food. It is used in animal feed, and also it has got applications in the development of many industrial products, many industrial products. This table shows the importance of cassava starch for direct consumption. Then a lot of modified starches are being developed recently, which has got a lot of applications in food industry, animal feed industry, in pharmaceutical industry, and all. Similar to cassava, sweet potato is another very important crop, nutritious crop, a climate resilient crop that has got a very high nutritional potentials, antioxidant contents. All this enables sweet potato to be also a future smart crop in the era of climate change. And some of the important studies, this I will be highlighting the impact of climate change on when a study conducted by in my group by a few of my postgraduates, postdoctorates, PhD students, we found the climate resilience of these tuber crops, especially cassava, sweet potato, greater yam, elephant foot yam, and taro, are the resilience. It is more robust to change in climate compared to the major other crops like rice and potato. So these are the two crops that we have compared, and at different climatic scenarios, it could be observed that these crops are really climate resilient. And a few other studies to find out the climate suitability and the geographical suitability, how the suitability will change in times of climate change in 2030 and 2050. Here also we could see that in many of the areas where other crops are going to fail in giving good yield, cassava and other tuber crops like especially elephant foot yam, sweet potato, and all are going to give a better resilience to the impact of climate by giving a better yield. So these are also very important studies that shows the potentials of these crops in the future climate change era. And most of these tropical tuber crops, they have got some of their livelihood, they ensure the livelihood security of about 200 million Indians. They are climate resilient and they have got diverse applications. And the weaknesses, I am not going into the very detailed explanation of all this due to paucity of time. And if you see the four major strengths of these crops, they are highly biologically efficient compared to many other crops in terms of its biological efficiency, as well as in terms of its energy production in megajoules per kilogram of the nutrients and all. If you see, these crops are highly efficient. And their second most important trait is they are resilient to climate change. Third most important trait is these crops are found in our studies that they are ideal crops for agroecology based sustainable production intensification that aims at greening the green revolution. And also they are multi-purpose crops. Again, this slide shows what is the energy production. If you calculate, see that per day energy production by major food crops, you can see that tropical tuber crops have got very high energy production per hectare per day on a unit area basis. And also they have the capacity to survive under dry conditions by extracting water from deep soil layers, controlling stomata closure, and shedding the leaves. And this is a very important information. If you see the global warming potential of some of the important tuber crops vis-a-vis other crops, you can see that in the case of rice, the global warming potential, if it is 1,221 gram of greenhouse gas per kg of rice produced. In the case of cassava, it is only 21. And in the case of potato, it is 24. And for meat, mutton, and all, it is comparatively very high, the global warming potential of these food crops. So definitely, they are going to play a very important role in climate change era. So they are ideal crops for sustainable production intensification. I have already mentioned. Why? Because these tropical tuber crops are very ideal crops. It has been found in our research studies that they are very good in cropping systems, in coconut-based cropping systems, in banana-based cropping systems, in rice-based cropping systems, in maize-based cropping systems. All these different types of cropping systems, they go well as an intercrop as well as sequential crops. And the farmers are gaining a better yield whenever there is a climate-related catastrophes. And another important point is they are ideal components for integrated farming systems. And also our studies on conservation agriculture also show the better performance of these crops when we integrate tuber crops in cropping systems in conservation agriculture as well as in organic farming also. They respond very well, especially crops like elephant foot yam. They respond better to organic farming. When most of the crops like rice, wheat and all reported a reduction in yield in organic farming, most of the tuber crops, due to their peculiar physiology as well as the long crop duration, they actually yield a slightly higher yield than conventional farming system. And the country, India, is now last 2, 3, 4 years, is going ahead with a new system of farming that is called natural farming. And we also have been doing research in understanding the science behind natural farming, and a lot of new information has been emanated, which also show that the tropical tuber crops, along with the trees and other vegetables and other crops, perform better in ensuring food security as well as nutritional security to the poor and the tribal farmers who mostly depend on these tropical tuber crops across the globe. Then planting, if you want to improve the value chain of these tropical tuber crops, some of the major issues of concern or of interest should be, one is we need to supply quality planting materials of climate resilient varieties. And in order to strengthen the food value chain, we need to develop value addition and new food products that are locally preferred by the farmers need to be developed. And the farmers, most of the farmers are smallholder farmers, and they need to be grouped into a cluster-based approach so that their capacity to bargain will improve. So in this respect, the establishment of farmer producer organizations by the government of India during the last 3 years to develop about 10,000 farmer producer organization is one of the most important aspects we have to consider while in strengthening the bargaining power of smallholder farmers when they by scaling their economies and by improving their market standing by collective negotiation. As on February 2023, there are reports say that 16,000 such farmer producer companies were established in India. So now I want to conclude by a few points that the maintenance of local breeds is very important. Biodiversity conservation is very important because out of the 6,000 plant species cultivated for food, fewer than 2,000 contribute substantially to global food output, and only 9 account for 66% of total crop production. So unless we maintain the biodiversity and the locally adaptable breeds in each village, in each state and in each country, that will actually strengthen our genetic base, and which in turn will improve our climate resilience. Then biodiversity conservation, I have already told, that is very important. Then climate resilient crops and varieties need to be incorporated into cropping systems. So when we develop cropping systems with the climate resilient varieties and crops, that will actually ensure farmers from a great economic loss in one crop will be compensated by a gain in another crop. So agroecology based sustainable production intensification is very important in the years to come if we are to sustain the food system for a sustainable world. And in this respect, tuber crops have got a very important role to play because they are the source of sustenance for more than 2,000 million of the world population. I think with this, I am concluding my speech. Thank you all.
Thank you so much, Dr. Biju, for this very interesting inputs. I think it was great that you could start your presentation with the overall food situation. That was, I think, very complementary also to the previous presentations, reminding us that we are very far from meeting the SDGs objectives, especially related to hunger by 2030, which is getting very close now. It was great that you could remind the importance of this kind of crops in being able to at least get closer to the goals in terms of food for people throughout the world. And really interesting to see the fact that it's crops that are mostly used now by small-scale farmers, and the importance then for farmers to organize amongst themselves to be able to reach out to the markets and also be in a better bargaining situation with the agri-food system, which also I think links back to what Dr. Hilbeck was saying about the industrialization of farming, which is also the industrialization of the food systems and the capacity of farmers to negotiate with these huge organizations that are dealing with the food systems. Maybe one deepening question regarding that is regarding this question that we also mentioned at the very beginning with Dr. Keberhab about the competition between local traditional foods and the hyper-processed foods that are advertised on TV and in the media and everything. How do the local populations relate to the tubber crops, and how do you manage making these foods attractive and maybe sexy for the local population so that they desire this food instead of the hyper-processed food?
Thank you, Dorian, for the question and your query. Tuber crops, mostly tuber crops in our situation, in Indian situation, are grown by very poor and economically, socially marginalized sections of the society, and it's a source of livelihood for about 200 million Indians. And as you suggested, this tropical tuber crops, we need to change the food habit of the newer, younger generation by developing value-added products that have got locally adaptable importance. So we are now working on developing a number of designer foods, incorporating tuber crops, millets, fruit, banana, and including all this, we are wholesome food products are being developed. And also through strengthening the farmer producer companies that have now come up throughout the length and breadth of the country. They are being trained, and in places like agri-business incubators, very small holder groups, small farmer groups are trained, and they are strengthened so that they will go to their community or locality and develop their own small units in developing value-added products from these tuber crops. So otherwise, the new generation cannot be able to relish the kind of food preparations with tuber crops that the older generation used to enjoy. So in order to cater to the needs of the new generation and according to their food habits, new products are being developed, and that is now catching up in a big way. And tuber crops have got a very important future in almost most of the countries, especially in the tropical and subtropical countries of the globe.
Thank you so much, and thanks again for the presentation. That was really interesting.
Thank you.
I would propose now that we move on to a little wider discussion. Just one further encouragement to write your questions in the chat so that we can introduce them in the discussion later on. And maybe to get started, there's a few points that came out from the different presentations and the different discussions. One of them, I think, that comes back quite often is you all spoke in a way or another on the need to change the direction into which we're going. And one of these big questions is how do we make this change? Because we all saw that only technical changes cannot be the solution as such. They can help, they can support. We saw the percentages of improvements in Dr. Kebrab's presentation in the beginning. They can definitely help, but they cannot be the solution as such. So in your view, how can the cultural direction into which we're going change? And also in terms of farming, how can we make small-scale farming desirable, or at least alternative forms of farming, more diversified forms of farming desirable for the farmers themselves, so that that's a direction that they look forward to? I don't know if that's an open question, so please go for it.
I was kind of hoping Angelica would speak first because I think she's got the broader purview. But I mean, I do think a lot of it is about leveling the playing field for the smaller farmers, or the farmers who they don't necessarily have to be small farmers, but to allow farmers to take up these agroecological methods, because there is a big hump to get over sometimes, especially if they're very impoverished already and aren't doing well, then they need help. Or if they're very invested already in this industrial model, then they also need help, because it's not like farmers make a lot of money. Even the industrial scale farmers, they have very small margins, and they don't have there's not a lot of, I mean, take the corn and soy region in the US. It's hard to find seed that isn't GMO seed, for example. I don't know if they even can find any corn seed that isn't, and that isn't already coated with a number of different pesticides on the seed itself. So what are they supposed to do? I mean, there's just the environment isn't there to provide them, to allow them to make these shifts. It's very, very difficult. So whatever policies that we can put in place to promote these shifts, that's really important. And I think that goes back to the root causes that Angelica was described so well, is that, we have a lot of, at least in the US, for example, we have all these lobbyists that are driven by very powerful interests of, who the big companies that produce the seeds, for example. And those are GMO seeds often, as I mentioned. So I think that's a real issue that's been in the stranglehold of those companies.
Thank you so much. Dr. Hillbeck, I think you were called in by Dr. Kremen.
Right. Well, I mean, I echo what she says. However, it needs to be clear in the different parts of the world, farmers never have a real good voice. Whether this is now developing farm in so-called developing world, or whether it is even our, the kind of industrialized farmers we have in Europe, which we have in different sizes as well. So I'm from a country, Switzerland, which has fairly by the numbers, we're a smallholder country, if you wish. Our average field size for farmers for arable fields is 20 hectare, which is nothing by comparison, to other European countries. However, we have a highly intensified agriculture. We have a lot of input. We have all the problems you have with all the pesticides and synthetic fertilizers. And even if it's not synthetic fertilizers, a lot of the problems in Netherlands, for example, but also for us, is all the animal waste that goes on our fields. Our fields have become basically dumping sites for animal feces, because we have way too high densities of animals in the Netherlands, for example, or also us. So they need to dispose of all the manure, and it's too much. So, things have gotten way too out of balance, and the farmers who are affected are not well represented. Let's put it this way. Our farmer association, we do have farmer associations, they have a loud voice and all that, but they have been co-opted and captured by the input industry, by vested interests. So many farmers are very frustrated because they really don't have a good representation of their needs. It's the needs of certain vested interest circles who can bring their voice to the table. And for the organic farmers, they are still by nature too small. So, it's a very different, it's nuanced, but the farmers themselves, they've never been on the winner's side, and they always struggle. And the genuine voice of those who actually work the field, they have, regardless where they are in the world, they have a very poor representation. And I think that needs to change everywhere. And maybe academics should start to become a little bit of a voice as well. We just stay back all the time and think like we shouldn't be bringing our voice to the table. I think we have to. I'm trying to, at least, let's put it this way, and, help those farmers on the ground, the grassroots, to get a informed and decisive voice. And making their voice heard. You know, I think that's the key.
Thank you. Dr. Kibrahab, you switched on your video. I don't know if that's a sign that you would like to speak on that.
Yes, I mean, it's early morning. My kids are getting ready for school and all that, so you might hear some background noise. But I think working quite a bit in low-income countries, and in particular, you know, where you see a lot of crop and livestock integration. Was some of the things that we asked a number of years ago when the State Department wants us to help, particularly in Vietnam, to come with low carbon economy. One of the things that what we did was we went around the country and basically asked farmers what do they need. I mean, a lot of people are not really that interested in just reducing carbon. I mean, it has to work with the with their production system and all that. And a lot of the times what we heard was there were challenges in terms of how to feed the animals and what kind of feed they need to provide. You know, as part of the whole system. You know, they're mostly mixed farming, so they have to make sure that they're tending to the rice crops as well as to the livestock. And most of them keep a small herd, maybe 1 or 2 cows and a few pigs and chickens and all that. So what we're trying to do was then to first of all figure out what is the feed map, what does it look like, what kind of feed they have access to. So be it just grass or rice straw or something like that, and then trying to improve the quality of things like rice straw by different methods, and then making sure that animals getting what they need in order to be able to produce milk or grow or draft power or a number of things that they've been used to. So we're trying to be more conscious about what the farmers actually need and how to integrate that. So it's not just about improving productivity, but a lot of times animals are kept for draft power, not really for food, but for energy as well. And so then we try to come up with ways to help make sure that those animals are kept well and there's a good welfare practices.
I think several of you mentioned the organization amongst farmers, and well, with regards to what you said, also in relationship with the governments, and that brings, I think, the question of the collective organization of farmers, their ability to be represented, and also the level of action at which we can change systems. Because there's some action that can be taken at the farm system. For instance, Dr. Kibrahab, what we are mentioning in the feed, that's definitely a decision that a farmer will take. But then there's things that are more at the landscape level. And Dr. Kremen, you were mentioning that the food supplies have to be available at the landscape level so that the farmers can get them to change their practices and everything. So would you say there's different scales of intervention? And I'm sorry, Dr. Biju, I don't know the Indian context so well, so please don't hesitate to bring in some inputs there. But what would you say are the different level of policy intervention at the national level? What can be done basically at the national level? What can be done at the landscape level? And what are the policy? What can policies trigger at the farm level in this different in this idea of also helping farmers organize themselves?
I can speak to the effect of policies that I have in California, for example. The state of California wanted to reduce emissions from the agricultural system, particularly methane emissions from dairy, because we have the biggest dairy herd in the United States. And the policy has really helped shape how people are doing business now in the state. And a few years ago, there was a lot of resistance to actually have this mandate to reduce methane emissions. But now you will see that a lot of farmers are actually coming to the state. Well, give us the tools, and then we'll be able to do it. So a lot of tools have been provided, a lot of help has been provided to help farmers to become more sustainable. And I see there's a lot of willingness now to actually go that way. And it doesn't harm, sometimes even improve the productivity. So at the beginning, policies are always viewed skeptically, and because it's hard to change. It's not just in farming, but in other places. Change is always difficult. But I think through negotiations and all that, the state really wanted to go like 75% reduction, and then engage the academics and others to say, okay, what's the reasonable thing we can do, and then so the 40% became something that's we can work on, and then in dialogue with academics, with NGOs, and with a number of different folks, then we were able to come up with the solution so that we can move the whole industry forward. And one of the problems you have is that there could be some leakage. For example, here in California, when there was this new legislation came up about how you keeping animals in cages, and what happened was the citizens basically said we don't want cages anymore, and so what happened was that a lot of farmers just basically moved out of the state and do the same thing somewhere else. So you don't want to have a policy that would lead to a leakage like that. I think it needs to be something that would actually help reduce or whatever change you're trying to do, instead of displace the change.
Well, I think what is also important is that policies are coherent overall. Because, I mean, we're seeing a lot of efforts right now in Europe. The European Union has given themselves some tough policy goals that are, some would say they're utopic. You will not reach them, but at least you have a goalpost where you try to aim for. However, at other levels of regulations and policy making, some of them are contradictory. They don't, on one hand, you say reduce manure, reduce your input of or output of nitrogen related fertilizer emissions and leakages in the soil, etc. And on the other hand, you're still paying them subsidies for increasing livestock numbers, or for size of your herd, or your sheer size of the landholder gives you the most subsidies. So you have absolutely no interest, and jeopardize your livelihood if you reduce it. So these policies need to be checked at each level to the little implementation regulations down, whether or not they're, you're saying one thing on the one side, but you're undermining it with another policy on the other side. And that work hasn't finished yet. And I think that's why we see the outcry also right now in the Netherlands, with a lot of farmers just hating all of these policies and resisting them, and leading to quite some political upheaval here in the EU, because those policies have not been explained well, and the subsidy system and the reward system has not been adjusted to it in a fashion. They've been getting a lot of money for installing exactly these kinds of large animal herds and infrastructure. They're all in debt because they followed guidelines and subsidies that the EU gave out. And now all of a sudden, comes this big turn where they say, oh, now you must cut this all in half. How should they do that without going bankrupt? So that it needs to be thought through quite well. And you need to take those people along and not just implement and say policy from top down. Then they do what Dr. Cabrera just said. They move somewhere else, shut down business here and go where they can do business as usual. And then,
And that's one side where they need also, and that's where G20 can be an interesting space, where they need to be also international coordination, so that
exactly
it's not as easy to move out somewhere else. And I just want to, I could go on with questions for I think a number of hours, given the level and the quality of your inputs. I just want to make sure that the people from the audience also get a chance to ask questions. I think we have 2 people that have joined the panelist discussion so that they can directly ask their questions. I'd like to maybe start with Joris Artsen. Sorry if I mispronounce your name. Would you like to ask your question? I think you should be able to switch on your mic and video and ask directly. And then we'll move afterwards. We'll take a round of answers, and then we'll move on to Dr. Sudish Wadaf.
Hello, everybody. Can you hear me? Yeah. So I've put my question in the chat. It's a bit similar on what Dr. Hilbeck has been mentioning. So it was mentioned by Dr. Kremen and Dr. Hilbeck that the industrialized systems are more extractive, so are leading to negative externalities, while the agroecological systems provide ecosystem services to society. So in line with what Dr. Hilbeck has just said, we should probably correct for this through incentives for more agroecological systems and taxes on the industrialized system that is leading to negative effects for society. So yeah, that was the point I wanted to make.
Exactly. I agree, and that's exactly what we need to do. There's different ways how you can do this. You know, by taxing is of course a straightforward thing to do, but there's other people who are more better in this, who do true cost accounting, for example, and then you have to close the loops, and the financial system has to go along with that. And there's also people there who've been thinking about this and developing concepts since decades. It's just they're not being brought to the table to the degree that they should deserve. But we do understand that these things need to be in parallel. We are in the uncomfortable position right now that we are facing all of these converging crises. So we have to do it all at the same time. And the key is to bring the right people at the right time to the right table. And we still tend to listen to those who have been responsible and have vested interest in keeping business as usual. Maybe a little lighter, maybe a little more efficiency gains here and there, but by and large, keeping those frames correct. And that needs to change. We need to be a little more radical in these things and bring those people to the table who had ingenious ideas how to do this.
Dr. Kremen?
Yeah, I'd just like to add to that, along with the taxes and the taxes on what we don't want, the incentives for what we do want, is also thinking about these enabling environments, and that often, there's some key barrier that needs to be addressed. So it may, incentives alone may not be enough. It could be about creating a program that is providing the specific information that farmers need in a specific situation, or conducting the research. All of these things have been, on the agroecological side, have been diminished relative to the conventional industrial side. And so again, so leveling that playing field, I think, is really important across a number of dimensions.
Thank you so much. I think Dr. Sudesh had a question as well. Maybe if you want to bring your question.
Okay, so thank you very much. In fact, I have some experience of working in Himalayas, wherein terraced cultivation is taking place, mostly rain-fed cultivation. As the human population is increasing, there is tremendous pressure on the land, and we have also noticed a lot of increase in population of wild animals, particularly the monkeys. So this is a big menace. In fact, they just spoil the crops, and there are wild boars also. Now, if we are also considering about conservation of biodiversity, how do we deal with this kind of encroachment? This is a conflict of demands on our resources, land resources, and we are just getting into the forest, which were originally meant for these creatures only. But then this is actually discouraging a lot of agricultural farmers and activities. People are actually leaving the agricultural activities and getting into some other alternative sources of livelihood. Now, this is a serious issue, actually. I don't know how best to deal with it, and in a real cost-effective manner.
I have some experience in different parts of the world. It's a very important and unresolved issue that you're addressing here. I see we have conflicts starting now in our alpine regions, where the bear and the wolf are coming back. We had exterminated them. They're coming back now, and they're starting to, become encroaching on human populations and on sheep herders, etc. But also I have experienced this and see that these debates are starting to become really really tricky in Eastern Africa, in Tanzania, the country I work mostly, with elephants and the large ruminants or the large grazers coming in, as like in your situation in the Himalaya, the human farmers are sprawling out more into the savanna, and and elephants, or some of the protection methods have worked. So elephants have started to reproduce or move and migrate to other parts. So there's bad clashes of interest there. I think a key issue is, and they need to be dealt with separately. We have to do different things in the alpine regions than what's happening in Tanzania. But the zoning is a key issue as well. Zoning and having an understanding of what goes where. And if you want to keep wildlife on one part and you want to have access to land and allow your sprawling farming community. And I know the zoning issue is not solved in East Africa. I don't know how it is for you guys in the Himalaya regions, but for us, there is no proper understanding and proper laws and regulations in place. And they're just settling wherever they want to, and then the animals come and say, well, this used to be our land, say. It needs to be organized. It needs to be organized, and you need to bring all the people together at a table to do this. So again, don't just have somebody in Dodoma or in, I don't know, New Delhi decide about this and then tell the people in the Himalaya what to do. You need to go there. You need to be there. You need to have those people there. They don't want to kill elephants, but they want to have a livelihood. So this needs to be negotiated. So negotiation is key there. And so.
Yeah, and it comes back probably to what Dr. Kremen was saying, to the role of adaptation and kind of research-based solution finding. Maybe I think Dr. Vishwanathan had also maybe one or two questions to address, kind of in the process of wrapping up our session now. We're going towards the end. And I don't know if it's possible to include also Sitala in the panelists space so that she can ask the question she has. But maybe Dr. Vishwanathan?
Okay. Just a couple of questions. Of course, one of the important thing coming out of the discussion is, of course, we have different frameworks that talks about rewarding the farmers based on their contribution, but somehow we don't have these frameworks not properly implemented. So the point here now, shouldn't we also think about moving beyond the narrow confines of profitability? Just look at productivity as well as profitability, rather than looking at farming as a profitable venture or a productive venture. Also consider in terms of the valuation, the benefits that goes to the biodiversity conservation, and also how much we have progressed. Of course, you mentioned about it. And any kind of very good examples that you can talk about where farmers are well paid for their contributions to biodiversity conservation in terms of incentives, or are there anything that can be taken to be scaled up and adopted in the southern part of the world, countries in the south? That's one question. And secondly, the other larger concern also came from the discussion is about the monoculture orientation. Of course, when we look at, I based on my own understanding, my own work, previous research on rubber plantations, basically a lot of rubber plantations are happening in this part of the world where I'm speaking, like Kerala, which I already mentioned that almost 27% of the total land use of the state is for rubber plantation, which is a monoculture. Even though Dr. Gangadharan spoken about the tuber crops research also, happening in the Kerala, in side by side, but so far, that kind of an adoption of tuber crops has not happened in Kerala, despite the fact that there is a research institute also looking at the promotion of tuber crop. So how do we actually make a significant shift towards the agro-ecosystem based approach, moving away from the industry? Because again, if you look at these crops, particularly the rubber that I'm talking about, we have much of these rubber plantations happening in the South and Southeast Asian countries, where it is being practiced as a monoculture. So how do we make a significant transition in this regard, where these countries are also the largest suppliers of food to the world? So how do we ensure the food security vis-a-vis moving away from the monoculture orientation? And another question, maybe any of you can reflect on. Thank you so much.
I think I have spoken enough already, so it could be also others chipping in. But also that question is it's taxing, it's politics, it's the negotiation, it's giving people a voice. I think there is no way around entering the policy sphere and the politics sphere, you know, and don't expect some wise leader to come and help you on this. You have to empower the people, and don't necessarily look to Europe or the United States either, you know, because we're dealing with a set of problems on ourselves and we don't have a real miracle remedy for this either, other than giving space for negotiation and understanding that change must come. And sometimes maybe it could be just enough to not give those anymore the space and the voice they have, who had their time. So, you know, it's all the industry power there who they find their way in this. That needs to be limited, and they need to be limited to the level of where the others are. And that's certainly not happening. The lobbyists of the industries are by far outnumbering those of smallholder farmers or the people who want change, at least in Europe, and I'm pretty sure that's the case in the US as well. Those need to be kept at bay. Okay, so we need to empower and bring more people to the table who have good ideas, proven ideas, documented success stories, and have a genuine interest in moving jointly forward in the direction where policies supposedly lead us.
Thank you so much. I see that Sitala has her hand raised, but I'm not sure you can speak from where you are.
Can you hear me?
Yes, perfect. And that will be our last question, I think, for today.
So just want to thank all the speakers for all their efforts and their hard work. Thank you very much. I came in a little late, so please forgive me if this question has been addressed, but regenerative agriculture has a lot of solutions and hope for the future that I feel could be transformative as far as coming up with some solutions for some of our problems. If we increase the fertility of our soil through biology, then farmers don't need to expand out into the forest so much. And I don't know, I know in the US, there's a regenerative farming bill that has come forward, and many farmers, and Elaine Ingham, who spearheaded this biological understanding of soils, has testified before Congress that if all the farms in the world were to go regenerative, then we could solve our climate crisis in 7 years. And that it's a win-win-win when we get the biology back in the soil. But as far as I can understand, most people don't have an understanding about the biology. Only chemistry in the soil is really focused on. So she's been actually able to help farmers. She has an excellent track record of helping farmers increase their fertility and their production yields by 200%. You know, so if we can grow more food on less land by increasing fertility, it's a fantastic solution, and it has less cost. But I think it's a shift in mentality from agro-business back to agriculture.
I think Dr. Kremen has this one.
Yeah, I think that's a lot of what we've been speaking about, although I'm a little bit hesitant about the specific label of regenerative, because it seems to mean different things to different people. And I don't know about the specific person that you're talking about or what they're specifically recommending or have found. But I think that we could talk more broadly about, there's a number of different terms that are used. sustainable intensification, ecological intensification, agroecological intensification, and this regenerative agriculture. But the main point is there are a lot of ecological practices, a lot of ecological processes that we can harness through the culture of agriculture. And we know quite a bit about these methodologies. Unfortunately, often they can't be sold. And because they can't be sold, they don't get promoted in the same way that a pesticide gets promoted or a GMO gets promoted. And they only get sold long down the chain after something has been produced through them. But I think the basic point about using these kinds of methodologies to intensify production and allow production to strong production that is multifunctional and produces other valuable things that we care about: soil fertility, storing carbon in the soil, storing water in the soil, being climate resilient, promoting the biodiversity, the agro-biodiversity that's needed on the farm, in the soil and above ground. All those things also help farmers to stay put, and they don't have to, they don't exhaust the soil and they don't have to move on. So they're all super valuable. That's what we're talking about here, I think, is how do we create the policies that will promote those forms of agriculture, including regenerative, but also agroecological, et cetera, when we're pushing against these very strong economic forces and this very concentrated corporate structure that wants to sell other kinds of products, GMO seeds, pesticides, large tractors, et cetera. And that is really very dominant. That's I think that what this discussion is largely, that a large part of the discussion revolves there.
Right. I would also say all solutions are welcome that help rebuild and regenerate our ecosystems. And obviously, we have to start from the soil when it comes to agriculture, with culture big in capital letters. So we were speaking about agroecological approaches. To me, that is regenerative agriculture is a term I know. It has a focus on a specific soil. All is good as long as it doesn't mask up at just continuing the same of the old with a little less bad. That's not good enough anymore. The times where little less bad would have been good enough to kind of steer the Titanic in the right direction have long passed. That would have been the 70s or 80s, if you ask me. Now we have to do it the hard way. We chose as a global population, or at least in the West, to go to the end until you see, everything is now in a dysfunctional state of affairs. Now we have to do it all at the same time. So a little less bad is definitely not good enough anymore. We have to really do transformational changes, and whatever helps there is welcome. Whatever dresses up as in disguise of doing business as usual, just a little lighter, is not okay in my view. And so we have to keep that separate, and keeping that separate and understanding what is a bit of the trick in the future.
Thank you so much, Dr. Hillbeck. I think that's a really great conclusive speech for the session today. We're really grateful to all of you. We're wondering whether we can maybe beg you a little bit in the coming weeks, because as I mentioned in the beginning, we're finishing the policy recommendations. Like we have a first draft that we're polishing now, and maybe if we can take a little bit more of your time to have a feedback on the policy proposals that will come up later, that would be really helpful for the work that is going on. And for the quality also of what will be delivered to the G20 governments that will meet up for their official final meeting in September in India. Thank you so much to all of the audience also that came up today, and all the people that will watch this later on and benefit from the outcomes of this. Thank you so much from your time. I know, Dr. Kremen, it's a little bit well, it's very early in the morning in California, so thank you so much for the efforts also, and it's still very early now, and we're looking forward to seeing you back and working with all of you in the future, and maybe I don't know if Dr. Vishwanathan, you would like to say a final word.
Just a final word. Actually, maybe just for your own kind of information, the Amrita University has a school for sustainable development, where we have around 100 PhD scholars working on such issues of sustainable development in the villages adopted by the university. So definitely we would like to connect with you in terms of undertaking research also on some of these topics which are being talked about today. We would like to have interaction with you in future in various capacities. So thank you so much for joining us at this short notice and with your busy schedule. Thank you so much.
Thank you as well.
Best regards to all of you and have a very nice day. Thank you so much.
Same to you. Thank you
Thank
very
you.
much. Bye-bye.
Bye-bye.
Stay safe.